So we're going to jump to chapter 8.2, just because some profs teach this. So I think it's good to know what integration by parts are. We know limited integration techniques right now. There are lots of them. All right. So this is a method. It's essentially like product rule. So the formula, we're going to develop the formula here. How do you take the derivative of a function, which we'll call u and v? Two functions being multiplied together. What's product rule? What does it say? Okay, so I'm going to say u times v prime plus v prime times u. No, v times u prime, sorry. Right? That's just product rule. If we want to go back, we would integrate it, correct? So if I said, okay, well, we integrate both sides. The left side, if I take the integral of the derivative of this, what am I left with here? Just this, u and v, right? Because they cancel each other out. So I get u times v is equal to, now the other side I'll just put the integral on both like that. I have integral of u v prime plus integral of v u primed. Okay, I'm going to rearrange this. 2. This one, I'm going to isolate this, and I'm going to move this over to the left side. So the formula becomes u v prime is equal to u times v minus the integral of v times u prime. I just rearranged this. I essentially moved this over to here. Okay? Now, v primed, we're going to write dv for that. Okay? dv. Because it's v prime. Yeah. And I'm going to write du for u primed. This is the integration by parts formula. I will give it to you. It is used for integrals with a combination of algebraic and this is the key part, transcendental functions. So what's a transcendental function? Anything you can't use algebra on. E to the x, natural log of x, the trig functions, etc. Those are all transcendental functions. Okay? So when you get a regular function like x, x squared, some sort of polynomial, coupled with one of these, sometimes you can't use u substitution, so you have to use integration by parts. Okay? Also, when two transcendentals are put together, we'll see that in a sec. All right. So the formula you get, all right? So let's just practice this. If I said, what is the integral of x e to the x? You may be tempted to do u sub. If you're going to do u sub, I'll show you what happens if you do u sub. What would you want to make u? What would be your inclination?
Yes.
E the x? Just x?
Yes.
Oh, ex. Okay, so if you make u equal e to the x, then du is equal to e to the x dx, right? But we have this. So that's not going to work to sub out, right? If you make u equal to x, then du is equal to dx. But then the integral is just, don't write this down, u e to the u du. That's the same integral. Okay? So none of these seem to work. So we have to do integration by parts because we have a regular function, x, and we have a transcendental function, e to the x. So what you have to do is we're going to use this formula. Okay? So you have to pick what is u and what is dv. It's up to you. Okay? Is it easier to integrate or derive usually? In general, is it easier to integrate or derive? Derive. Okay. So you want to pick one of these you're going to have to integrate. The dv you have to integrate. Okay? So you want to pick the thing. This is going to sound really weird, but it makes sense in my brain, so hopefully it makes sense in your brain. That is the most complicated, but you're still able to integrate it. Okay? So you have a choice. Do you want this to be u or dv? And then, obviously, do you want this to be u or dv? So of those two choices, x and e to the x, which one is more complicated, but you can still integrate it? E to the x, all right? Because what's the integral of e to the x? E to the x. So we're going to say u is equal to x, and dv is equal to e to the x dx. You have to take the dx with it, okay? So if you look at, so we've decided what those are. The formula has u, v, v, and du. All right? So I have to get du out of this. So I have to take the derivative of this. What's the derivative of u? Or of x, sorry. Yeah, so du is equal to x dx. Is equal to dx. Wow, sorry.
Which one is d? Which one is d?
There you go. The derivative is 1.
Equals dx dv.
dv is equal to e to the x dx, yeah.
Maybe we should use another letter.
I know, this is what the book uses though. The u and the v's look very similar to each other. Okay, so du is equal to dx. Now, how do I get rid of the dv? I need to get v. Other one. The other one. Yeah. Because I have dv, so if I integrate both sides, what's the integral of dv? V, right? What's the integral of e to the x? E to the x. Okay. Now we can use our formula. Formula says it's u times v minus the integral of v times du. What's u? X. What's v? E to the x minus integral of v, which is e to the x. What's du? Dx. So we have one more step. We need to get rid of the integral of e to the x, which is e to the x. So it's x e to the x minus e to the x, tack on a plus c, and that's your answer. So it allows us to solve more complicated integrals. Okay? All right. We're just going to do 2 more examples, and that'll be it for this part. x squared natural log of x dx. Does integration by parts work on this? Or sorry, does u substitution work on this? No. How would, if you had this, would you need integration by parts? You don't. Why? Because if I say u is equal to natural log of x, what's the derivative? 1 over x dx. So that subs that out, right? U substitution is your go-to because it's easy, all right? But if it doesn't work, then you have to go to integration by parts. All right. So we have to decide what is u and what is dv. So of these two choices, you have x squared, you have natural log of x. Which is the only one you know how to integrate? X squared, right? Integral. You don't know how to do the integral. If I just said, here's, right on here. If I said, what's this? You don't know how to do that, right? You know how to do the derivative of the natural log. You don't know how to integrate just the natural log. You can actually do it using integration by parts, but we're not going to, okay? But you don't know how to do that. So if you have a natural log in there, the odds of it being dv are like almost 0, okay? So u is going to be the natural log, and dv is going to be x squared dx. So we got to figure out du. What's du? 1 over x. And then for dv, we have to integrate both sides. I should say du is equal to 1 over x dx. And that gives me v is equal to, what's the antiderivative of x squared? There you go. And then you just put it into the formula, which is u times v minus v du. Our u is natural log of x. Our v is x cubed over 3 minus the integral of v, x cubed over 3, du, which is 1 over x dx. So we still need to do that integral, but we want to clean it up a bit, right? Because it's kind of gross right now. So we can simplify that. I can pull the 1/3 out. X cubed over x is x squared. Oh, excuse me. Does that make sense? Okay. So what's the antiderivative of x squared? It's x cubed over 3. Tack on a plus c. We could put the 3's together and get 1 over 9. We okay? All right. One more example, and then we're done. No, I'm not going to do that one. Okay. Actually, we're going to call it done there. All right. There is another one I could do, but we don't really need to do it since this. mostly part of Math 101. You'll see that. So, all right, I'm just gonna give you a few questions, and then we'll do one more mini lesson, and then tomorrow we can finish the course. All right. So 8.2, the questions I want you to do are page 521, numbers 11, 13, 17, and 23. 4 questions.